So here is the topic of our projects. So this is batch number 131. So we are doing on identification of chemicals in fruits and vegetables using IoT. So here I am Ankita and this is my following team members. So these are the agenda, that is abstract, objective, introductions, literature review, design methodologies, implementation, testing, input, output, include demo videos. And the last is conclusion and future enhancement. So here is the abstract that fruits and vegetables are highly nutritious. So as we know that fruits and vegetables are highly nutritious and they are the main food that every human should consume. But with all these benefits, there are some disadvantages also. So as we can see that the fruits that are sold in the market, the fruits and vegetables, it contains some of the chemicals. So these are not purely natural. So to increase its productivity, they include some chemicals, but which is not good for human health. So to avoid all those chemicals, to detect all those chemicals present on this vegetables, we are doing a small project on it. So this is the aim of the project. The aim of the project is to tell that how to identify and calculate the chemical percentage present in fruits and vegetables. So by using the gas sensors and DHT1 sensor, it will help to identify the chemical level. So if anyone has having spreading the chemicals on the object by using JSM, we can alert from the message. So we can get the alert from the message if any chemicals is present there. So this is, and next is the scope of the project. The scope of the project is to find the chemical level in fruits and vegetables. So we have to eat healthy foods. So this is the scope of our project. Introduction. So residues of harmful chemicals in fruit and vegetables poses risk to human health. So as we know that all these foods and vegetables, those contains the chemical products. These are really harmful for the immune system of the human being. So laser induced breakdown spectroscopy techniques are unsatisfactory for detecting harmful chemical in fruits and vegetables. We applied here metal nanoparticles to fruits and vegetable samples to improve the availability of LIBS, to detect the trace pesticides and heavy metal residues present in the samples. So the nanoparticles, here is the literature review. So monitor of the pesticides in fruits and vegetable sample has increased in the last year since most countries have established maximum residue level for pesticides in food products. Despite the wide-ranging benefits of using pesticides in agriculture, several incorrect applications can result in high and undesirable levels of the compounds in the produce that reaches the consumers. So here is another literature review by Arotia F. Adam and Calvo Carrascal. So he said that general processing factors estimates the effect of the processing methods, pesticides on residue levels, and the disposition of the residues in the processed products, calculates and considered by the joint FAO WHO meeting on pesticides residues as follows: PF equal to residues in processed products mg kg minus 1. So we have to see that PF values. Methodology. So this process work is to find the chemical. So this process work is to find the chemical percentage level in the fruits and vegetables. In order to provide an early alert when the object contains harmful chemicals, large number of detectors which will measure the temperature and the gas concentrations are deployed in this place. When there is detection of harmful of those chemicals, an alarm sounds At the same time, this is to design the use of GSM technology. The Arduino continuously monitors the value from the sensor. If the values are not within range, it will take decision and indicate using GSM network. With the use of Arduino and GSM technology, we are going to implement the harmful chemical deduction systems. So here the module 1, collections of required components. So here we have used the components like Arduino Nano, THT11, that is for measuring temperature and humidity. Then for MQ135 air quality, this is for the gas sensor module. Then NODEM ESP at 266. This is for Wi-Fi development boards. So this is the standard and policies of our projects. That is Arduino. It's like an open source with that allows to share and create the documents that will contain the live code, visualization and equation and narrative text. So standard used is ISO IEC 32346. So this is the implementation, architecture diagram, data flow diagram, ER diagram, sequence diagram, collaboration diagram. So this is our architecture diagram. Here we have used the power supply and the Arduino, which is connected with GSM and LCD, along with gas sensors and the DHT11 sensor. So this is the data flow diagram. Take fruits and vegetables. So first we have to take the sample, that is our fruits or the vegetables, whatever we will use. Then place gas and DHT11 sensor. So we have to place the gas and DHT11 sensor on the fruit. Amplifies the signal. Arduino compiles the program. Then get the values and output. Then ER diagram. So this is the user that will help to sense the object, amplifies the signal, monitor the values. If values greater, then it will display the result on the LCD. So, so this is the testing. So here we are going to do the following testing: unit testing, integration testing, functional testing, white box testing, black box testing. So unit testing. So what do you mean by unit testing? Unit testing is to design to test the small pieces of the functionality rather than the system as a whole. So it will use to design those small pieces of the functionality. Unit testing can be performed from the bottom, starting with the smallest and lowest level models and proceeding at a one time. So here is the input, elimination of bugs, detections of errors, and the test result will be bugs are eliminated and errors are detected. Integration testing. It is defined as a type of testing where software modules are integrated logically and tested as a group. So we can see that it is tested as a group. A typical software project which will consist of multiple software modules. So it will contain the multiple software modules coded by different programmers. The purpose of this level of testing is to expose the defects in the interaction between the software modules. Input, user friendliness, then consistentness. Test result is user friendly. So functionality testing. Functionality testing is performed using the functional specification provided by the client and verifies the system against the functional requirements. So testing the main functions of any application, it will involve the following testing of the system. It will check whether a user can freely navigate through the screen without any difficulties. So it will check the following conditions. Check the accessibility of the system of the software, and usage of the techniques is to check the error conditions. So uses of these testing techniques to check for the error conditions. So input is if then else, do while, case switch. So these are the following inputs and test result. All loops are testing. So white box testing. So white box testing, it will involve the following testing of the software code for the following. the internal security holes, broken or poorly secured parts in the coding process. The flow of the specific inputs through the code, it will give the expected output, and the functionality loops. So black box testing is on the validation of the functional requirements. Black box testing will give the extraction from the code and will mainly focus on the testing effort on the software system behavior. So input and output. Here we can see input, and these are the following outputs. So as we can see, monitoring of the pesticides, temperature 33.60, and then we can also see the air quality is recorded. So pesticides are tested, not tested. This is the result. Demo video, as we can see. And here last is the conclusion. The localization of the pesticides in food. It will varies from the nature of molecule type and portions of plants and materials, environmental factors. So by using these pesticides, we can increase the quantity of the food, but not the quality of the food. So by this, as I have already explained in the introduction, that by using those chemical pesticides, it will increase the productivity, but it won't increase the quality. So pesticide chemical food will spoil in less days. It is easy to find the chemical percentage in fruits and vegetables. So our application will help to detect those pesticides. So here is the future enhancement. This project predicts three chemical compositions. So this our project basically focus on three chemical compositions. So it will detect like nitrate, sulfur, and phosphorus present in fruits or either in the vegetables. In future, more number of chemical contents will be found and make the experimentation with various fruits and vegetables. So impact of the intensification technologies on pesticides has been applied as an effective method for reducing the pesticide residues. So this is the web references and the video links from where we have taken our references. So here is last is the references. So this is the plagiarism report of our PPT. So as we can see, this is the poster presentation. So here is the introduction of our model and the methodologies. So as we can see that in the methodologies, the main proposal is to find the chemical detections. That is, as we have mentioned already about the three gases, so it will allow to find those three uh, gases using the following sensors. So as we can see, the sensors. And here is the end of our project. Thank you. So here is the coding part of our project we are doing on Arduino. So we will first connect with port COM3. So we have clicked on it, and now as we can see our screen, so we will connect with the Arduino with, as we can see, there is a blue flashlight. So it is already connected to the web server. And now as we can also see on the screen, that is connected to triangular along with IP address. So it means the connection is already done with the Arduino with the help of Wi-Fi development board. So now we can check it, the particular IP address and particular device only through which it is connected to hotspot. We cannot check on other device. We can check only on particular device where it is connected to the help of hotspot. Okay, so as we can see, now we took our first sample and we collected along with the sensor. So here it is recording the temperature, humidity, moisture, quantity. So as we know that we are using here DHT11 for measuring the temperature and humidity, and MQ135 for air quality. So next sample is the tomato that we are using. So this is our second sample. So in the same way it is recording the temperature, moisture and air quality. So here we can see that it has detected our pesticides. So this is the output of our project. Thank you.